Okay, so in this video we've got two lines written in vector form, and if they're not written in vector form, before you can do this you would have to write them in vector form to convert them from Cartesian to this format. You're asked to find the point of intersection and the angle between the lines. Okay, so what you do is you look at the x component and the y component to begin with. So you've got 6 plus lambda, and that's got to be equal to, if they intersect, that's got to be equal to 5 minus mu. And for the y component, we've got minus 1 minus lambda, and that's got to be equal to, if they intersect, at minus 3 plus 4 mu. Right, then we need to rearrange each of these. So we've got lambda plus mu is equal to minus 5. Now take great care when doing this because it's very easy to make a mistake. And then what I'm going to do is say minus lambda minus 4 mu is equal to minus 2. We'll call that equation 1, we'll call that equation 2, and we'll just solve them simultaneously. We don't need to do any multiplication. I can just add the two equations together and lambda will be eliminated. So lambda minus lambda gives me nothing. Mu minus 4 lambda, 4 mu gives me minus 3 mu. And minus 1 plus minus 2 gives me minus 3. Therefore, mu will be equal to minus 3 divided by minus 3, which is 1. We'll now substitute either into 1 or 2. They go into 1. We've got lambda plus 1, because mu is 1, is equal to minus 1. That gives it lambda is equal to minus 2. So we've got a value of 1 and minus 2 when the x and y components meet. But we need to check to see if it works for the z component, because it might work for these two, but it possibly might not work for the last two. So you must do this last bit here, which check the z component. So the z component is 4 plus 3 lambda. So we'll just take our value of lambda, substitute it in here and see what we get. So we get 4 plus 3 times minus 2, that's 4 minus 6, which is minus 2. And then for this one, we got minus 3 plus mu. And we'll put our value of mu in, which is 1. So we're going to get minus 3 plus 1, and we get that z is also equal to 2. Now, because these agree, it means that these two lines do actually intersect. And the z point, the z coordinate where they intersect is minus 2. We just need to now go back and just consider these two here to find the x and y coordinate where they meet. Now, if here you do not get agreement, then the lines do not intersect, and there will be possibly skew lines, and we'll look at that in a later video. So these are consistent, and so the lines intersect. So using x is 6 plus lambda, lambda is minus 2, 6 minus 2, x is 4, y is minus 1 minus lambda, so that would be minus 1 minus minus 2, which is 1. So therefore, the lines intersect at the point 4, 1, and we got the z component from the previous bit, minus 2. And if we look at this GeoGebra applet, okay, and I'll include the coordinates, include the link in the video. Obviously, the lines meet at this point here. Okay, and we click, and we can see we've got the correct point. Now, the next step is to find the angle between the two lines. So, to find the angle between the two lines, we don't need to consider the point on the line. We just need to consider the directional vectors, and then find the angle between the directional vectors. If it comes out to be obtuse, we'll just subtract it from 180 to find the acute angle. If it turns out to be acute, then we stop there. We'll stop there with the problem. Okay, so going back. So for the angle, we need to find the angle between the directional vectors, as I've just shown you. So write down the two equations again. So we're going to need to consider this vector here and this vector here. So considering the directional vectors. Okay, so using the scalar product, V2 will be arc cos. Arc cos means cos to the minus 1 of the dot product, or the scalar product between the directional vector of the first one and the directional vector of the second one, divided by the magnitude of the vector of the first one and the magnitude of the vector of the second one. We're only going to consider these two here. So that's going to be arc cos of 1 times minus 1, minus 1 times 4, plus minus 1 times 4, plus 3 times 1, divided by the magnitude of this one, so it's going to be the magnitude of 1 squared minus 1 squared plus 3 squared, put brackets around the minus 1, and the square root of minus 1, 4, 1 squared, 4 squared, and 1 squared, again putting brackets around it. So writing that out, okay, so it's going to be arc cos, so we've got minus 1, minus 4 plus 3, which makes minus 2. And then we've got 1 squared plus 1 squared plus 3 squared, so that's going to be square root of 11. And then we've got minus 1 squared plus 4 squared plus 1 squared, it's the square root of 18. And then if we take a calculator out, that will give 98.17. That's not acute, so therefore we need to find the acute angle, like I said, which is 180 minus 98.17. That gives you 81.82 degrees, which is 81.8 degrees. So we'll just go back and look at the GeoGebra applet. Again, I'll remind you, it will be in the notes of the videos, the link. Okay, if we click on here, we can get you see we've got the angle there that we wanted. So the actual angle we found was the angle between the two directional vectors, which is this one here. But we actually want this one here. This one's actually acute, even though it doesn't look so in the diagram. But if we move it around like that, we can see perhaps that is the one that we wanted to find. Okay, so you can move this around, you can look at it from different points of view, which is quite good. One of the great things about using GeoGebra. Okay, so this has been a video to show you where two lines intersect and to find the angle in between them. I hope you've understood, and I thank you very much for watching.